All right, so like I said, today we're learning a new gas law. It's called the ideal gas law. And so let's just review real quick the characteristics of gases we learned about already. We learned about pressure, how hard the gas molecules collide, volume, how much space it takes up. We learned about temperature, that's how fast the molecules are moving, and we measure that in Kelvin always. And then today we're going to be talking about the moles of the gas, which is how much of the gas there is. Okay. Now, the key thing that I want you guys to note somewhere on your paper is that moles, we always measure it in terms of moles. Okay. And I know that might sound really stupid, but I'm saying this because a lot of times when we look at gases, sometimes the number will be given to us in grams. Okay. So you have to convert from grams to moles. Okay. So just make a note of that somewhere. We denote moles with the letter N. It's a lowercase n. And then we just need to make sure that if we have grams, we turn it into moles. Yeah. No, you already have this in your previous notes. Yeah, we're just talking, just little notes on moles. Okay. Okay, so just keep that in mind. You always need to turn grams into moles when we're working with the ideal gas law. Okay. All right, so we did this one before, so we're going to skip this problem. It's just converting from grams to moles. If you need a little refresher, you just find the molar mass. So O2, oxygen is 16, so you do 16 plus 16. That means it's 32 grams per mole. And then you just do 12 grams, and then you divide by 32. That's pretty much it. Okay. So this is in your previous note, so look back there if you guys need it. But we're going to go into what the ideal gas law is, okay? So do not write all of this down. This is just general information. But basically, if you know one of these three or three of these four characteristics, you can figure out the one that's missing. Okay, so that's what the ideal gas law is. So I want you guys to write down the ideal gas law. It's this right here. It's PV equals nRT. And then we got what all the symbols mean down here. You make sure you guys write down the equation, and then I'll explain the rest of it in a second, okay? Okay, so a couple things to note is that when we are using the ideal gas law, pressure is always going to be in terms of ATM, okay? So you need to make sure that the pressure is in terms of atmospheres. Your volume has to be in liters, so just make sure if it's in milliliters, you turn it into liters. Okay, the lowercase n right here is obviously moles. So if it's grams, you have to turn it into moles. Okay, the temperature is always in Kelvin. So again, degrees Celsius, you have to turn it into Kelvin. And then R is the one that's the best because it is always the same number. Okay, this is a gas constant. And because it's constantly the same number, so just make sure you guys jot down R right here. R will always be 0.0821. Okay, no matter which ideal gas law problem you're using or solving, it'll always be 0.0821. Okay. All right, so with that being said, let's go into, we'll do one example together, and I'll have you guys try one on your own. If you think you can try it on your own, number two, you guys can just ignore me and try solving it. But it's pretty much the same thing we've been doing for the other gas laws. We just need to identify which variable the numbers are, and then just plug and chug into the equation, okay? So let's look at this problem. So it says calculate the volume, okay? So we're looking for volume of 9.5 moles. So which of these variables is 9.5 moles? Is it PV, NT, or R? N, yeah. N is moles, so 9.5 moles. So your N is going to equal 9.5 moles. Okay. And it says that it has a pressure. So the pressure is 0.88 atm. And then the temperature is negative 15 degrees Celsius. All right, so again, very similar to what we've been doing. We're just pulling out the numbers and figuring out what variable they are. So before we plug this in, what's one thing that we have to do before we put all these numbers into the equation? What do you guys think? Exactly. You got to turn the temperature from Celsius to Kelvin. So you have to add 273.15. So make sure you always keep that in mind. You have to turn Celsius to Kelvin. All right, so that's all your variables. I'm going to give you guys about 2-3 minutes. See if you guys can work with the person next to you to plug this into the ideal gas law and figure out the volume. And then I'll have you guys try one on your own, and then we'll be all done for today. Okay, so first thing we got to do is turn the temperature into Kelvin. So we got 273.15 and then subtract 15 because it's negative 15. So your temperature in Kelvin is going to be 258.15. All right, after that, we just plug it into this equation. So our pressure is 0.88. So P is going to be 0.88. We are looking for volume, so we can just put in V. That's going to equal our moles, which is 9.5. Okay, our R value is always the same. It's going to be 0.0821. And then the temperature is 258.15. Okay. Any questions on how we plug this in? Okay, so P is this right here, looking for V, and 9.5. R is always this number, and our temperature is right here. All right, so what we have to do is we need to isolate the V. So if you take a look at 0.88 and V, they're being multiplied, right? So in order to move the 0.88 to the other side, we just need to divide that side by 0.88. So on the top of the fraction, we'll have 9.5 times 0.0821 times 258.15, all divided by 0.88. Okay, that's it. So the math is pretty simple. But let's see if you guys got it. We're going to plug into the calculator. So 9.5 times 0.0821 times 258.15. And then we're going to divide that all by 0.88. Okay. And then so we get a final answer of 228.8. So our volume will be 228.8. Okay. And if you take a look at the volume, it has to be in liters for the ideal gas law. So it's going to be in liters. And that's it. Okay, so the algebra, not too difficult for this unit. It's just moving variables over and solving for the missing one. All right. Any questions on that one? Well, not too bad. Alrighty, guys. So I'm gonna give you guys about maybe 5 or 6 minutes to try out this problem right here. I'll put it a little bit bigger in a second. Okay, but I want you guys to find the mass of N2 in a 4-liter container at 0.88, 85 ATM and 25 degrees Celsius. Now, before you start, I do want to give you guys a little heads up. If you guys notice, the problem is asking for mass, right? So if you guys think back to what we learned so far this year, whenever you're looking for mass, what's the unit of measurement for mass? How do we measure mass? It is that you're going to need to use, that's molar mass. So if you guys go on a scale and you put something on the scale, what does it give you? Grams. So that means for number 3, the answer has to be in grams. Okay, so keep that in mind as you guys solve out this problem. Okay, you're going to have to find the answer in grams. So whatever you're using to find, or whatever your variable you're finding in the ideal gas law, you got to turn it into grams at the very end of the problem. So I'll give you guys a couple minutes to think that over, work on that with the person next to you. You'll need the periodic table. It's my little hint to you guys, and then we'll go over it in a couple minutes. Alrighty, guys. So I'm gonna scroll down a little to go over this. Okay, so we're gonna be calculating the mass of N2 in this container. So let's figure out the variables that we have. That way we can figure out the missing variable. Okay, so you guys should have noticed that for liters is volume. 0.85 ATM is going to be pressure. And then this guy right here is going to be your temperature. However, you do need to convert this into Kelvin. And so that's going to be 298.15 Kelvin. Okay. Everybody go with that? Those variables? Probably not too bad. All right. So if we take a look at the ideal gas law, which one is the variable that's missing that we need to find using the ideal gas law? Yeah, moles. We're looking for N. Okay, and the reason why is because R is always the same number, so 0.0821. And then we have P, we have V, we have T, so we're just looking for N. So in this case, in this problem, we're looking for moles. Okay. All right, so we can just plug in our numbers. So P is going to be 0.85. So I'm going to plug in 0.85. Our V is 4. We're looking for N. R is always going to be 0.0821. And then our temperature is 298.15. Okay. All right, so we need to isolate the N. So we got to move these two guys to the other side. Now they're being multiplied. So again, same thing. We're going to divide on the other side. So if we divide on the other side, we'll get 0.85 times 4 on the top divided by 0.0821 and 298.15. Okay, so I'll pause right there. Any questions on how we got to this point? We're just moving these numbers to the other side by dividing. All right, so let's plug this into our calculator and we can get our final answer. So again, multiply the stuff on the top. So 0.85 times 4. Going to divide by 0.0821. Divide by 298.15. And that's going to give us about 0.14. So I'm going to write 0.14. Oh, excuse me. Thank you. So we get 0.1. I'm going to round it up to 4. If you want to keep it at 138, 139, that's totally fine as well. Okay, and that's going to be moles of N2. All right. Any questions on that part? Hopefully not too bad. All right. Now, unfortunately, we are not done because the problem's not asking for moles. It's asking for mass, right? And mass is going to be grams. So we need to turn moles into grams, which should be pretty easy because we just use the molar mass. So if you guys pull out your periodic tables, okay, I gave you guys an easy molecule to look at. N2 is just made out of nitrogen, right? So if we take a look at nitrogen on the periodic table, what's the molar mass of just nitrogen? Yeah, 14. So N2 is made out of 2 of these. So 14 plus 14 is 28. So the molar mass of N2, so N2 is going to equal 28 grams per mole. So in order to turn this into grams, we just set up a fraction. We put 1 mole on the bottom. That way the moles can cancel out. And that'll be 28 grams on top. So all you got to do for your calculations is 0.14 times 28. 0.14 times 28. That'll give us a final answer of 3.92 grams of N2. Okay. And that's going to be it. That's about as hard as it'll get today. Yeah, it's about as hard.